I'm recording, so you can watch later. Alright, I'm gonna go through, we can do like the entire process now, we're just putting it all together. I got the 5 problems on there, but there is not very much room. I would not do your work on there. I would do it on in your notebook or something. And then I got the answers attached so you can check on there as well, but it takes me like basically a full page to do most of these, so I don't know if you're gonna want to try it in that little space right there. But now some of you are probably taking it as a challenge, so you're gonna try to do it anyway. It wasn't really meant to be a challenge. Question. Alright. So body number 1. So I got y equals x over x minus 3. So what you are going to want from the original equation is whether or not there are asymptotes to start with. So we're looking for horizontal and vertical asymptotes. Are there any horizontal asymptotes in number 1? Yes, because the highest power is tied, right? Top and bottom. So you take the coefficient in front of the highest power on the top and the coefficient in front of the highest power on the bottom. So that's 1 over 1. So you have a horizontal asymptote at y equals 1. So if you want, you can go to your graph and throw that on there. Alright. Basically, I gave you this so you can like have a graph there. And then you can do your work somewhere else. Or very, really small. Vertical asymptotes is when the bottom equals 0 and the top does not. So when does the bottom equal 0? X equals 3 at that spot. Does the top also equal 0? No, at x equals 3, does the top equal 0 also? It does not. So there's a vertical asymptote at x equals 3. Throw that on here too. Alright, so now I'm going to take the derivative. So you could bring the bottom up and use product. I think it's easier to just use quotient. I guess it's up to you. I'm going to do quotient, so the bottom times the derivative of the top. Top bottom, 1 over the bottom squared. So that'll give me, so it's like x minus 3 minus x over x minus 3 squared, which is really just negative 3 over x minus 3 squared. And then I'm going to set the top and bottom equal to 0. I'm actually going to do this right now too. I'm going to rewrite it like this. Because I know later on I'm going to have to take the second derivative. And in my opinion, I think most of your opinions, this form is easier to take the second derivative of this form. You know what I'm saying? So I'm just like putting it there now to make my life easier down the road. Here, let me turn my closed circuit TV for you. Alright, then I set but this I'm only using like for later to take the second derivative. I need to have a top and a bottom, so I need to set the top and the bottom equal to 0. So if I set the top equal to 0, negative 3 equals 0 never happens. If I set the bottom equal to 0, remember you can square root, cube root, whatever root, both sides, 0 is still going to be 0. So it's really just x minus 3 equals 0. So we really have x equals 3. So that is a critical point, and it goes on your number line. And then I take a representative point for each of these sections and plug back into what level? First derivative, because what does first derivative tell me? Slope, which is the same as like telling me whether it's increasing or decreasing. Positive slope means increasing, negative slope means decreasing. So if I plug in like 0, 0 minus 3 is a negative number, but then I square it, which makes it positive. So I'm plugging it in here. And then a negative divided by a positive is a negative. So f prime of x is less than 0, which means f of x is decreasing in that first section. How am I doing? Am I going too fast? Am I good? Alright. Second part here, so let's say I took like 10, 5, whatever, it doesn't matter. When I subtract 3, it's still going to be positive. When I square it, it's still going to be positive. Then a negative divided by a positive is a negative. So we're decreasing over here as well. So on your test, you'll have these blanks over here. Increasing, decreasing. Relative max, relative min. It's never increasing. Are there any times that it's a relative max or min? No, because it's just decreasing the whole time. Remember, relative max, f of x would, if I want a max, f of x would switch from what to what? Increasing to decreasing. If I want a min, f of x goes from decreasing to increasing. It is decreasing, but don't put that it's decreasing from negative infinity to infinity. It's not decreasing the whole time, because where is it not actually decreasing? Then x equals 3 because it's an asymptote. So you have to kind of write it like around 3. That's the information we got from the original first derivative. Any questions yet?
No, sir.
Ethan, Trey, you guys good? You're ahead, okay. So now I'm going to go back and I'm just rewriting like the derivative was negative 3 times x minus 3 negative 7. So when I take the second derivative, you guys get what I'm saying? Like if I do this for this, if I write the first derivative like this, I have to use quotient rule. I don't really want to do that if I can avoid it, so I'm going to choose this setup instead. Your head might be in the way of some other people. So take the second derivative here. Negative 2 times negative 3 is 6. Reduce the power by 1. And don't forget to multiply by the derivative of the inside, which in this case is just a 1, so it doesn't really change things. But it's not always a 1. And I would write this like 6 over x minus 3 third. We still Gucci? Alright, so the top equals 0, 6 equals 0, it never happens. The bottom equals 0. We're going to get x equals 3, right? Again. So I'm going to set up a number line again. Put 3 on there. now what you're trying to fill out is concave up, concave down, and point of inflection, and I just need the x value for the point of inflection. So I'm going to pick a representative point from this region and plug back into what level if I'm looking for concavity. Second derivative, double draw. So let's say I put in 0. 0 minus 3 is negative. A negative number cubed, still negative. Positive divided by that negative. So over on this side, the second derivative is less than 0, it's negative. Which means we're concave down. So I can throw it in my, I've got my answer slide over here. Pick a point from this section over there. 3 to infinity, let's say 10. 10 minus 3 is a positive number. A positive number cubed is still a positive number. A positive divided by a positive is still a positive number. So the second derivative is greater than 0. Which means the f of x is concave up. So be careful here, because even though I'm not asking you for the y value of the point of inflection, you can't put a point of inflection if it's not a point of inflection. So it would be super tempting to go over here and write x equals 3, because the concavity did change, right? But the point of inflection has to be a point. And if you're trying to find the y coordinate of that point, I don't need the y value. It's helpful to try to find it, because if you try to plug 3 back in here to find the y value, you get 0 at the bottom. So it is not actually a point of inflection. So if you put x equals 3 here, you're gonna lose some points. Because there is not a point of inflection. Is that part Gucci? Okay. Then I'm gonna make my kind of my summary number line. Figure out which shapes go on the graph, and try to put them on the graph. I'm going to make another number line. Now, I only had one critical point in this one, but if I had, like, multiples, some from the first derivative, some from the second derivative, I would put them all on here. We'll do one like that, too. And then, like, on top, I'm going to write if f of x is increasing or decreasing. On the bottom, I'm going to write whether f of x is concave up or concave down. Where is it? I'm just doing it like below. I just want you to page. Yeah. So I'm just like summarizing these last two graphs basically. So we are decreasing here and decreasing over there as well. So I'm just grabbing that information from prior. That information from prior instead of getting concave down. Concave up. What? So then I can make my shapes. So concave down is the N. And you want the decreasing part of it. So is that my right arm or my left arm? Right? That's my left. So it's the part that's going down. So yeah, I don't know if that's weird. So now it's my right, like if you're from your side. So concave down can either be that or that. This part's increasing, this one's decreasing. So we want this one. So that shape goes here. And then concave up. One of those two things, we want the one that is increasing. So the one on the left or the one on the right? No, we still want decreasing, right? So the one on the left or the one on the right? The one on the left. That. So then my job is to fit those two shapes into my asymptotes. So I know I have to have I know this shape has to go to the left of vertical asymptote, and then this shape has to go to the right. Well, I can't start it like up here, right? Because I got the horizontal asymptote to worry about. So this part where it's leveling off has to level off like near the vertical asymptote, so it's going to be down there. Same thing over here. You've got to, this part is where it levels off as we go to infinity, so you've got to make sure that matches up with your horizontal asymptote. Somewhere around there. So you want to draw something like that. I understand no one's making a perfect graph. Being super picky about that. So that's the whole thing. That's one of them. You'll have 4. You can do all 4. I'll grade your best 3. If you can only do 3, I'm grading your best 3. Which would just be the 3 that you did. Questions on that one? Thank you, okay? You're violently pointing at your desk. Yeah, it's a negative. Oh, for that? Okay, yeah, you would cube root it first. You would cube root it first, then you'd square it. So it ended up positive anyways, because you would square it. Is that what you asked? Yeah. Okay. I thought we were going to do that, and I just stopped worrying about it. Any questions I can answer on number 1? Yes. What's the problem? Because it's not a vertical asymptote. It would be wrong because it is increasing at x equals -2. It doesn't stop there. Yes. X value is fine. So I was planning on doing number 2. Does that work for you guys? Or do you want to like try it first? What helps you best? I'll work on it, and you can see my work. You can check it as you go. Or as you're coming up with questions, shout them out. There's no asymptotes in this one, right? Because you have no fraction. So for this 2/3 thing, make sure we're all on the same page with how you do this. If you can look up for a second, if I can interrupt your work. No matter what number I plug into this, if I raise it to the 2/3 power, it's going to be positive. Let's make sure we understand that. Even if I had a negative number inside, like say I plugged in 0, 0 minus 14 is a negative, and you do the cube root first. You do the bottom first, and then you square it. So if I cube root a negative, yeah, that's negative. But then I'm going to square it. it's always going to end up positive. Does that make sense? The cube root, square root process order there, Mr. Zeller. Yeah. Yes. Yes. Well, you should go through the thing though, because what if it was like an odd number on top could still be positive if you started with a positive number. Okay. Yeah. Oh, goodness gracious. Yes, thank you. Is that what your handle's for too? Okay. Thank you. Hey. Okay. Thanks. Jesse. Have a good one. I didn't even multiply the 14 and 7. I just left it because it's not going to result in anything anyways. I don't need it. You can. No, what I marked you wrong for is if you said it was a point of inflection, but it was an asymptote. So I'm saying, like, check the y value to make sure that it actually is a y value and is a point. And then but if you included the y value and there is a y value, I'm not going to mark it wrong. That's just extra information. 2, I actually did find the y value for the point of inflection because I didn't have any other points to put on my graph. Like there were literally there's no other point. I didn't know where to start my graph. Like I knew my shapes. I didn't know where to start my graph, so since I had this already, I just plugged it in. You gotta have something to kind of build around, you know. You can't just throw a shape on there like willy-nilly. Can't go all willy-nilly. Willy-wally. I want to do number 4 after this. So if you're like working ahead, jump to 4. I'm not going yet, but yeah, where?
The point of inflection when you plug it in to find the y value.
Yep.
Is that not negative 14 plus 14?
Yeah, so that's 0.
Right.
And then what's 0? What's the third root of 0? 0. Then what's 0 to the first power? 0. So it's 0.
Oh.
Yeah. Okay. Mackenzie. So that's why I want to do number 4 because we haven't had those in the first 2 examples. Number 3 does as well. So if it's increasing from that'll have a relative min, right? So there'll be a relative min at x equals 4. Is it at 4? Okay, so it's decreasing prior to 4 and increasing after. So if you picture in your head decreasing and then increasing, that creates a min, right? Where if it was increasing and then decreasing, that would create a matrix. Yes. Dwayne, did that look like you were answering or listening as well? That help? Kenzie, you're good? To find the y value, yes.
So that's a fine graph, right? Because the point of inflection is at -2 and there's no asymptotes.
That is fine. Doesn't even like you get described. Top notch. Those actually those are good curves. Kind of jealous of you. So when you're done with 2, I would go to 4 next. I think that's the next most difficult. Well, I don't know what's most difficult, but I would like to go through a couple things on 4. How many are still plowing through number 2? Okay, I'll wait a couple minutes before I move the answer key. Well,
It's just going to be
if you think back to when the very first example I did, I included 3 things that I'm actually not going to put on the test. So the one I did at the very beginning of the unit had a hole, removable discontinuity. That won't be on the test. We also find the x, y intercepts of that one. That won't be on the test. Wait, what do you mean? You still need asymptotes. But we did one that had a removable discontinuity where you get 0 over 0 and it makes the actual circle in the graph. That won't be on the test. That answer your question? Yeah. Someone else have their hand up? I would like to talk through like the summary of number 4. Not yet. I know some people aren't even started yet, but I just want to make sure we're all on the same page with what's going on there. What do you mean randomly? For which one? So you need, I want y values for the relative max and min. Yeah. Can I remove the answer key to the answer is 7? Or, why did I say 7? Because we've got a 7x. Number 2. Can I move on from number 2? Nobody's done number 7 yet? Not even 7 on there. I don't know why I said that. So I'll do the number line thing for number 4. Once I feel like people are there, I want to talk through it. Squared away there. Half of x. I need to see over here. But if you don't write it there, it's right. Any other question, or were you just graphing in the air? You guys can cheat on the test. Just sit up there and be like, air drawing graphs. Watch for that. Yeah, see. Sorry. Yeah, first of all, do you know why it's a min? So that makes like a bottom, which is a min, right? And then that's a max, because the opposite.
Yeah.
So then, yeah, to get these two, I plug into the original. I plug these two x values into the original to get these two. I know I see. Yeah, that's what I want to do. It's a little tougher because you're combining numbers. You can put it in more combat. So we're decreasing from like negative infinity to 0. So we put decreasing there, and then increasing 0 to 2. So you can there. So and then packing down there. I'm sorry, cracking up. Yeah.
What is he doing?
0 to 2. So yeah, this is like from negative 0.
So what do you do with that middle part?
0 to 2.
Basically, so it's like it's still compound.
Yeah.
Is it? Yeah, because you're compound is negative 3 Right. So it's like right in between stuff. Well, it's the, so you have to use your pin. Yeah. So that's what it's mentioned. Right. Right. So it's comp up decreasing all the way to 0, 0. Yep.
This
You're
here.
going to 0, 0. It's comp up increasing. Right. All the way up to your max. Huh? You know what I mean? Okay, so it starts increasing at 0. Right? Yes, sir. What's up? What's up? Okay, exactly. Yeah. So I have this one. I have that one.
So I want to do number 4. I just want to make sure. The number line, because that gets a little bit trickier compared to some of the other stuff we've done. So any critical point that I have, even if you're not here yet, I would strongly recommend paying attention to what I'm doing. So I have x equals 0 and x equals 2 for my first derivative. I have x equals 1 for my second derivative. So they all go on my number line. And then on top, I'm going to write whether the graph is increasing or decreasing in that interval. So it's a little weird because like there's a 1 on my number line, but 1 didn't have anything to do with what was going on up here. But that's okay. I know the graph is increasing between 0 and 2. Well, between 0 and 2 just happens to be 2 intervals. So those both are increasing. It's got to increase all the way from 0 to 2, so I just write it at both spots. And then we're decreasing. Same idea for concavity. It's concave up all the way up until 1. So there's 2 intervals before I get to 1. And I just make them both concave up. Concave down from 1 to infinity. There's 2 intervals. I just make them both concave down. And then my shapes, decreasing concave up, increasing concave up, increasing concave down, decreasing concave down. I think, Delaney, you were saying, where do I start? Because I don't have asymptotes. That's why you find the y values of the relative max and relative min. So I can build around those. 0, 0, 2, 4. If you did find the y value of the point of inflection, which I'm not making you, but if you did, it's right here. And then that splits your graph up into 4 parts. And I can build my shapes around those 4 parts. So all the way up until 0, it looks like this. 0 to 1, it looks like this. 1 to 2, your concavity flips. 1 to 2 on, it looks like this. That was kind of rushed. I think I waited too long to do it. But for the number line, yeah. your question? Okay. Kenzie, you're good? Okay. Ben, are you good? Ethan, are you good? What, yeah. Let me know what I can do.
Just the number. Just explain the number again.
So you just write that out. You just copy it. So increasing from 0 to 2, which is big enough. So it's increasing. Just look at this. Where's the increase? So it's there. And it's decreasing from negative 2 to right. Okay, it's gonna give up. Negative infinity 1. So all of this. And down. You gotta know your shapes. Decreasing concave off. Concave off is a U. You're doing it upside down. Concave up is a U.
Oh, my fault.
The decreasing part of it. That's
increasing.
complete opposite, actually. Do you have a quick question?
So are critical points allowed from that concave?
Yeah.
So I will write it down.
Yes.
So the only time there's no critical points is when asymptotes.
Okay, asymptotes are critical points too, actually.
So I write that down too.
Critical points are basically anything that would bonus number.
Okay. So I write it down no matter what.
If the top or the bottom of either derivative is equal to 0, that's a critical point.
Okay.
Do you get it though, or just a copy?
No, I got it.
Okay.
Makes sense. I know how to do it. And then graph it.
So then I know I have
Is that
0, 0.
you have 2, 4.
Yep.
Your max.
Yep.
And I did find the next way.
Perfect.
So that's a 2.
Yep. Now this shape
This shape.
goes to the left of 0. Take that shape to the left of 0. That shape goes between 0 and 1. Yep, and then it's going to like curve another way. Maybe 1 and 2. Yep. Good. So we're just doing this again tomorrow, basically, just more practice. Everyone's half my class is gone. I don't know what's going on. Thanks for staying. See you later. Have a good one. You too. Test Thursday.